Hey there folks, in this video we're going to take a look at another Iranian Math Olympiad problem in which we have a very interesting equation. We're given that 2 plus root 3 to the nth power equals 5042 plus b times root 3, and we want to solve for b where n is a natural number and b is an integer. But before I go on, consider subscribing and ring the bell to not miss my latest videos. So first of all, let's talk about powers of 2 plus root 3 and 2 minus root 3. Obviously, these two are conjugates, so that means that their first powers are conjugates too. And if I square them, if I square the first one, I will have 7 plus 4 times root 3. And if I square the second one, I will have 7 minus 4 times root 3. So that means that their squares are conjugates too. And interestingly enough, if I cube the first one, if I cube 2 plus root 3, I should have 26 plus 15 times root 3. And if I cube the second one, I will have 26 minus 15 times root 3. So that means that their cubes are conjugates as well. And we can go on with this forever, but the thing I want to say is that since 2 plus root 3 and 2 minus root 3 are conjugates, their squares, their cubes, and so on are conjugates too. So generally, I can say that a plus b to the nth power is a conjugate for a minus b to the nth power. And we can easily prove this using the binomial theorem, but I'm not going to prove it in this video. I'm just going to use it to solve our problem. So in our problem, we are given that 2 plus root 3 to the nth power equals 5042 plus b times root 3. Now, based on the fact that a plus b to the nth power is a conjugate for a minus b to the nth power, we can say that 2 plus root 3 to the nth power is a conjugate for 2 minus root 3 to the nth power. And that means that I can express this in either of these two forms. It either equals 5042 minus b times root 3, or it equals b times root 3 minus 5042. Because both of these two expressions are conjugates for this expression. And actually, I can express these two expressions in this form, positive or negative, the quantity 5042 minus b times root 3. So let's call the first equation number 1, and let's call the second one number 2, and then let's multiply number 1 by number 2. So if I do that, I will have 2 minus root 3 to the nth power times 2 plus root 3 to the nth power equals positive or negative the quantity 5042 minus b times root 3 times 5042 plus b times root 3. And then we need to go ahead and simplify this equation. So on the left-hand side, we have two exponents with the same power, so we just need to multiply the bases and raise the result to the nth power. So we will have 2 minus root 3 times 2 plus root 3, and then the whole thing raised to the power of n. And on the right-hand side, we have two conjugates multiplied to each other, so we can use the difference of two squares. And if we do that, we will have positive or negative the quantity 5042 squared minus b times root 3 squared, which is going to be 3b squared. Now notice that we have, again, two conjugates multiplied to each other on the left-hand side. So if you use the difference of two squares again, we will have 4 minus 3, which is 1, and 1 to any power is simply 1. So on the left-hand side, we have 1, and on the right-hand side, we have this expression. And from this, I can say that 5042 squared minus 3b squared equals positive or negative 1. Make sense? Great. So at this point, I can say that we have two scenarios. Either this expression equals negative 1, or it equals positive 1. So let's go ahead and talk about the first scenario. So let's say 5042 squared minus 3b squared equals -1. So let's go ahead and move this to the right-hand side and move this to the left-hand side. If you do that, we will have 5,042 squared plus 1 equals 3b squared. Now at this point, I need to use a lemma to solve our equation. This lemma states that if a is an integer, then 3 does not divide a squared plus 1. So in our case, since 5,042 is an integer, we can say that 3 does not divide 5,042 squared plus 1. But obviously, on the right-hand side, I can say that 3 does divide 3b squared. So we have an equation that the left-hand side is not divisible by 3, but the right-hand side is. So we have a contradiction, and we can say that this scenario is not possible. So let's talk about the second one, in which we have 5,042 squared minus 3b squared equals positive 1. So let's go ahead and isolate b. So we will have 3b squared equals 5,042 squared minus 1. And then let's divide both sides by 3. And let's take the square root of both sides. So we will have b equals positive or negative square root of 5,042 squared minus 1 over 3. Now, if we use a calculator, we can say that this equals positive or negative 2,911. But notice that b is a positive quantity. But you might ask, how do I know that? Well, let's go back to our question, and I will explain why it is a positive quantity. Notice that n is a natural number, so if we expand this out, if we expand 2 plus root 3 to the nth power, it is obvious that the coefficient of root 3 is going to be a positive quantity. So that means that b is a positive quantity, and that means that negative 2,911 is not valid, and the only solution we have is b equals positive 2,911. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and smash the like button if you find this video helpful.